Let's talk about the architecture of a deep neural network. What do we know about a few general rules that we can use in how we pick the architecture of the deep neural network? There are two aspects to the architecture. The first is how many hidden layers do you have, and the second is how do you make the connections between those hidden layers, right? And so there's a theorem which is known as the universal approximation theorem, which says that if I have a deep neural network with just one hidden layer, given that I provide the hidden layer enough number of hidden units, I can approximate any continuous function which is bounded on Rn, right? Any continuous function which is bounded on Rn, I can approximate using a neural network with one hidden layer, given I provide it with enough number of inputs to the point of me having any finite non-zero amount of error. So this theorem would have us believe that architecturally we really don't need many layers. In fact, the whole point of deep learning, the sense of deepness in the deep learning would not exist. Probably I wouldn't even be doing these videos if that was true, because there'd be no deep learning. But it turns out that deep networks are useful. There's a lot of evidence, empirical evidence, that shows that when we use deep neural networks, we can get better results in terms of generalization results. Deep neural networks generalize to unseen data better than neural networks with just one hidden layer. Also, the theorem does not put any limit on the amount of hidden units I might need in that one hidden layer, right? And in fact, an exponential number of hidden units as compared to the inputs might be needed for me to be able to learn any particular function. In fact, some empirical evidence shows that if I use more hidden layers, I can get away with fewer parameters and lesser complexity than just using one hidden layer, right? So there's a strong case for us to use multiple hidden layers. So that's about hidden layers, the number of hidden layers that we want to have. The second thing is how these hidden layers are with respect to one another, and we would see that we have specialized kind of through empirical evidence we have figured out that there's specialized kind of architectures that work for different domains. So there are convolution neural networks which work really well for computer vision. There are recurrent neural networks which have backward connections that work really well for sequence processing and so on. The next point is about connections. How do we make the connections? We don't have a whole lot of general rules there. So what works and what does not work. We generally have to go by what our experiments indicate. There are many ways people do connections. There are sometimes fully connected architectures. Sometimes you don't want fully connected architectures because there are too many parameters in that case. We want some of them to be not fully connected, partially connected. In some other cases, we have skip connections where we connect a node at one layer to not a node in the next layer, but the next to the next layer, and so on. So that's about connections. We don't know a whole lot there. And this was about architecture of a deep neural network.